Hello everyone, and welcome. Have you ever wondered how engineers design bridges that can withstand tremendous stress? It all comes down to understanding continuity. In this video, we are going to explore continuity and differentiability, a crucial chapter in your ICSE Class 12 Maths syllabus. We'll break down complex concepts into easy-to-understand pieces, packed with examples and exam tips to help you score high. Let's get started. So, what exactly are continuity and differentiability? Simply put, continuity means a function has no sudden jumps or breaks. Differentiability means we can find the slope of the function at any point. These concepts are essential because they form the foundation of calculus, which is used in physics, engineering, economics, and many other fields. Plus, this chapter carries significant weightage in your ICSE exams. Now, let's dive into the first key concept, continuity. A function, f, x, is continuous at a point, c, if the limit of f, x, as x approaches, c, exists, and is equal to the value of the function at, c. Think of it like drawing a line without lifting your pen. If you have to lift your pen, the function is discontinuous. We also need to check continuity from both the left and right sides of the point. This ensures there's no sudden jump or break in the function. Okay, let's define what we mean by a limit. Limit, the value that a function approaches as the input approaches some value. It's like getting closer and closer to a destination without actually reaching it. Understanding limits is the first step to understanding continuity. Now, let's move on to differentiability. A function is differentiable at a point if its derivative exists at that point. The derivative represents the instantaneous rate of change of the function. Visually, this means the function has a smooth curve at that point, without any sharp corners or cusps. If you can draw a tangent line at a point on the graph, the function is differentiable there. Here's a key formula for you. F, x, equals lim, h right pointing arrow o, f, x plus h, f, x, h, f, x, equals derivative of f, x, h equals a small change in x, f, x, represents the slope of the tangent line to the function at point x. This formula gives us the derivative of a function, which tells us how the function is changing at any given point. Now, let's talk about the relationship between continuity and differentiability. A differentiable function is always continuous, but a continuous function is not always differentiable. Think of it like this, differentiability is a stronger condition than continuity. For example, the absolute value function, x, is continuous at x equals 0, but not differentiable. Remember this relationship, it's a common trick question on the exam. Here's another important formula to keep in mind, d dx, x caret n, equals nx caret, n1, d, dx equals derivative with respect to x equals variable, n equals constant power. This is the power rule, one of the most fundamental rules for finding derivatives. Make sure you know it inside and out. A common mistake students make is assuming that if a function is continuous, it must also be differentiable. This is not always true, as we saw with the absolute value function. Also, remember to check the limits from both sides when determining continuity. Now, let's solve a typical ICSE exam question. Q. Check the continuity of f, x, equals x caret 2 to 4, x2, at x equals 2. Uns. Step 1. Simplify the function, f, x, equals x plus 2. Step 2. Find the limit as x approaches 2, lim, x right pointing arrow 2, x plus 2, equals 4. Step 3. Find the value of the function at x equals 2, f, 2, equals 2 plus 2 equals 4. Since the limit and the value of the function are equal, f, x, is continuous at x equals 2. Continuity and differentiability are used extensively in physics. For example, in mechanics, the position of an object is a continuous function of time. The velocity, which is the derivative of position, represents the instantaneous speed of the object. Understanding these concepts helps us predict the motion of objects. Here are a few exam tips to keep in mind. First, always check for differentiability before attempting to find the derivative. Second, pay close attention to piecewise functions and check continuity at the points where the function changes its definition. Finally, practice a variety of problems to build your confidence. Let's quickly summarize what we've learned. We defined continuity and differentiability. We explored the relationship between them. And we solved a typical exam question. All of this, AI notes, doubt solving, practice tests for continuity and differentiability, is available free on Synapse. Study smarter, not harder. Start free today at synapse.omups.in. Master continuity and differentiability for ICSE. And please subscribe to our channel for more free lessons. Visit synapse.omups.in and start learning today.